In this video, I just want to do a few quick examples to highlight how we can determine the electron configurations for relatively early atoms in the periodic table. So I'm thinking, say, the first 3 periods of the periodic table, where we're primarily filling s and p type orbitals. So we've talked about there's 3 key rules that we need to follow. One is the Aufbau principle. The second is the Pauli Exclusion principle. And the third is Hund's rule. And so the Aufbau principle says we fill electrons from the bottom up. Pauli Exclusion says we put no more than 2 electrons per orbital, one with spin up, one with spin down. And Hund's rule says that when we have multiple degenerate orbitals, that is orbitals with the same energy, we put them in those 1 electron per orbit with this parallel spin before we start pairing any up. So let's do some examples. First, lithium. So lithium is atomic number 3. And it has 3 electrons. And so if I draw an orbital energy diagram for lithium, I'm going to have my 1s, my 2s. I'll draw the 2p's, though we're not going to need it. And we can see that as we start filling electrons, I'm going to start off with the Aufbau. So I'm going to fill from the bottom up. So I'm going to put my first electron here. And then Pauli Exclusion says I need to pair them. So I've now paired up 2 electrons in the 1s orbital. That orbital's full. And so now my next one has to go in the next lowest orbital, which is the 2s. So I'm going to draw it as a spin-up electron in the 2s orbital. It doesn't actually matter whether I draw that as spin-up or spin-down. That's arbitrary. The key point is that I have 1 electron in the 2s and 2 in the 1s. Let's try another example. We'll do oxygen, which has 8 electrons. So I have my 1s, my 2s, and my 2p orbitals. So in this case, again, I'm going to put my first 2 electrons in the 1s. I'm going to put 2 electrons in the 2s. I've now used up 4 of them, and I filled those. So now my remaining 4 electrons need to go into the 2p orbitals. According to Hund's rules, I'm going to say 1, 2, 3. So I start filling across with parallel spins. But now that I put 1 electron in each one of these orbitals, I still have 1 electron left. So now I have to go back and start pairing them. And it doesn't matter which one I pair up, but I'm just going to pair up that first one on the left. So this is the electron configuration for oxygen. Let's do one more example, and that is for phosphorus. This is in the 3rd period, and it has 15 electrons. If I draw the diagram over, you can't see that. Draw the diagram right here. We have 1s, 2s, 2p, 3s, and 3p. And so for my 15 electrons, I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we filled up with the first 10 electrons, the 1s, the 2s, and the 2p. I have 11, 12 electrons now in the 3s, up through the 3s. And now I have 3 left. So now Hund's rules, because these 3p orbital energies are the same, even though my picture is a little crooked, they're all the same energy. So I'm going to put 1 electron in each of those with parallel spin. And so that's the electron configuration for phosphorus. So again, the key 3 ideas are Aufbau, build up from the bottom up. Pauli Exclusion, no more than 2 electrons per orbital, 1 spin up, 1 spin down. And Hund's rule, when you have degenerate orbitals with the same energy, put 1 in each degenerate orbital with the same spin before adding any additional ones, for example, as we did with oxygen.